All right, so we have two types of statistics that we're going to look at. Descriptive and inferential. All right, got my pen here. So descriptive statistics are ones that are used to describe just elements or characteristics of a certain variable. If you want to describe the data, and that's all you want to do is just say, here's the data, we use descriptive statistics. So descriptive statistics, you know what they do? They describe. They describe. Describe. What do they describe? They describe elements or characteristics of the data. They don't make inferences about it, which is that's what inferential statistics do, but they just describe what it is. So what's an example of a descriptive statistic? The mean. Okay, so if you said, what's the average grade in your class, professor? I could give you the average grade, and that would describe for the group of people that take my class, what is their average outcome at the end of the semester when I assign grades. That would just describe it. It wouldn't tell you anything about it. It wouldn't help you to know how to improve it, or if it meant that students really learned statistics or not. It would just say, that's the mean, that's the average, there you go. Here's a number. Sometimes that's helpful, right? Because I have 35 in one class, I have 70 students, and so you couldn't just keep all of their grades in your mind, but you would say, so the average grade is a C? All right, what does that mean? See, descriptive statistics actually beg a further question. Is that good? Is that bad? Is an average of a C a good or a bad thing for this class? And that's what inferential statistics is all about, is asking sort of, well, what things make those grades go up and down? Okay, so that's descriptive. They just describe. They just say, here are the characteristics of the data. That's all they do. Now, they're very important and they're very good, but they're not very helpful at helping us to determine what we should do. Should you take my class? Should you take another class? That's where inferential statistics come in. Inferential statistics. Those are statistics that are used to infer, right? If you infer something, you're making a claim about the future. You're making a guess, if you will, and you want to substantiate what you expect to happen. And so inferential statistics infer something. You might infer from, say, the average grades in my class or the average grades in someone else's class. You might compare these descriptive statistics, the means of those classes, and say, Professor Frazee his students don't do as well as that other professor. She has much higher grades than he does. And so that's an inferential statistic. You might make a claim that our classes are statistically significantly different from one another based on descriptive statistics and inferring that we are pulling from the same population and that we are using the same assessment. Remember, because you have to use the same dependent variable in order to say that one is different from the other. For example, what if my grade average is a C and say a different professor, her averages are an A? You might really be, that's a curious difference, right? A statistically significant difference in numerics. But what you might not realize is that we use different assessments, right? So she gives she grades homework only, right? I never grade homework. None of this class homework will be graded. She uses homework as grades, and so that improves all the students' grades. But if we took the same final exam, my students would perform better than her students, right? So it's more interesting, it's more subtly nuanced than that. We can't make these big claims without understanding that we might be missing something. And inferential statistics helps us to compare like things, right? Apples to apples. And so you might want to do, for me, I could teach one of you one way and the other class a different way, giving you the same assessment at the end, the same dependent variable, and say, if I taught her method with one class and I taught my normal method with another class, and it's me and it's the same person, and then I give you what's called a common final where everybody gets sort of an assessment on the dependent variable, it's the same across the groups, then you might be able to make a claim that her style is better than my style. Or you might not be able to make that claim at all. You might find that the styles aren't different and that something else is happening in terms of those grades. Okay, so that's inferential statistics. Is that what are some examples of descriptive and inferential statistics? Well, descriptive statistics, some examples are going to be the very next thing that we learn. So the examples that we'll use are the measures of central tendency mocked. That will be the mean, median, and mode. 3Ms. No, this is not a product placement. My video is not sponsored by 3M, although I do love sticky notes. Post-its are great. So those are all descriptive statistics. They don't really do anything about inferring what will happen in the future or if there are differences between groups. They just tell you, here's the average, here's the middle, here's the most frequent. That's all it is. They're good, they're helpful, they help our brains conceptualize things that are too difficult for us to know on their own, but they don't do the sufficient work which we want research about people to do, which is to tell us, well, how can we improve outcomes? How can we move towards human thriving? How can we increase human learning? How can we reduce human suffering? They just tell us what is, right? They describe what is. They don't tell us what could be or what would be. And that's why measures of central tendency and measures of variability, MOVE, that would be range, variance, and standard deviation. I'm just going to abbreviate it here. I can write it out later. As you can see, I'm not a great artist. These are just describing, okay, how do those scores vary from one another? How much movement do they have in the data? That's it. Descriptive statistics like these, they're not very helpful at determining what we should do as people to get different outcomes. That's where inferential statistics come in. So the inferential statistics that we're going to cover, oh, I forgot, correlation is also a descriptive statistic that we'll talk about in this class at the end of the class. So included with measures of central tendency and variability, we'll also do correlation, which is a descriptive statistic. Inferential statistics include things like z-test, t-tests, ANOVAs, and non-parametric tests. So z-test is the first inferential statistic that we're going to do. First, we'll have to go through hypothesis testing, so that'll be in chapter 4. But these are all tests that are going to enable to say, okay, are these 2 things or 3 things or more different? And can we expect in the future that if we selected 3 different things, like say my online, hybrid, or in face-to-face, if we do that in the future, what can we expect the outcomes to be like? How much confidence do we have that those outcomes will again result in a difference or will not again result in a difference? And so that's what inferential statistics help us do, is to plan out for how do we change, how do we make policy, how do we make medical decisions, how do we make psychological decisions, how do we make educational ones that then are going to result in a difference across time. You need inferential statistics. Now, a couple things about them. This isn't a crystal ball. I don't even think I would like it to be. This is, however, the best way humans know to predict future outcomes. And that's to utilize data, descriptive statistics, put them into inferential statistics, and then glean from that what we can expect in the future with a certain reasonable sense of confidence. In fact, a quantified sense of confidence, that we know how often we'll be wrong in making those claims in the future. That ends up being a huge boon to humans. In fact, it's created science for us that we can use to better human lives, to increase human thriving, to make our world a better place to live in. And so we need these inferential statistics, but something to note about them is that they utilize descriptive statistics to get there. So you have to start with descriptive and we'll move on to inferential. Inferential statistics are used to draw inferences about a population. Instead of describing data like the descriptive statistics, we use that data to estimate what population averages would be, right? We take a sample And then we use that sample as a projection of what the entire population that that sample was drawn from would look like, with some reasonable parameters around it. Okay, so really quickly, to recap. Descriptive statistics describe, inferential statistics infer. That's it.